This would be ray AB. Just like we put the line segment or the line above the 2 points, is what we would call ray AB, with the initial point and one other point on that line. If there happened to be another point like this, you could call it ray AC. It doesn't matter. You would just pick the initial point and one other point to name that ray. Okay. The initial point and one other point. So an opposite ray are two rays that face opposite directions, they form a line. So for example, if I had ray AB that went this way, and I had ray AC that went that way, those would be two opposite rays. Ray AB and ray AC. Okay? They form a straight line together. If you put them together, they make a straight line. We call those opposite rays. And the last one is what we call sides of an angle. They are just two rays that form an angle. I actually lied, I have one more after this. Two rays that form an angle. So when we talk about an angle here in just a second, it's going to be made up of two rays. Okay. This would be an angle, right? We're going to talk about how do you name angles, what are we going to do with angles, but this would be one side of the angle, this would be the other side. So there'll be questions like name the sides of this angle. You would say ray AB and ray CD, or whatever, ray AC. Okay, we'll talk about that. So let's look at angles a second. How do we name them? Here's an angle made up of two rays, right? There are multiple ways we can name angles. Okay, one of the ways is by the 3 points that make up the angle. This is called the vertex. Okay, the vertex. This is the last one. Is the common endpoint of an angle. So if I asked you what's the vertex of this angle, you would say it's point A. It's where the two rays meet to form the angle. Okay. How do we name this angle? We can do it multiple ways. One way is we use this symbol. We use that for angle. Okay. Angle BAC. We always use 3 points to name an angle, and the only key is the center point has to be the vertex. When you name an angle, the center point has to be the vertex. So you could name an angle BAC or CAB. Either of those would appropriately name this angle. You could not name it BCA because the center point has to be the vertex. That makes sense? Okay. We could also name it angle 1 because that's the number on the interior of the angle. So those are the 3 ways we could name this specific angle.
So the middle always has to be in the middle?
Exactly. The vertex always has to be the middle point in naming an angle. Always 3 points, 1 on each of the sides, and the middle one always has to be the vertex. So if I give you a picture like this and said, name this angle. What's one way you could name that angle?
ABC.
Angle ABC would be a good way. What's the other way? CBA. The middle point always has to be the vertex. The reason, I don't know what that is. The reason we don't say angle B is because if I just said angle B, you don't know if you're talking about this angle, or this whole angle, right? You don't know which one you're talking about. So that's why we have to use these 3 points. And we always use the center one is the vertex. Okay? If there was a number here, the number could be either you'd have one like that and that. You could also call it then angle 1. But there happened to not be a number there. Okay? That's how we name in angles. If I said, what is the sides, name a side of angle A, B, C. What's one of the sides? What AB? What is it? It's not. Is it a line segment? Is it a line? Is it a ray? It's a ray. BA. Or if you said AB, either way, that's fine. Okay. Usually we start with the initial point where it starts and goes the other direction, but it doesn't have to be that way. What would be the other side of it?
CB.
Yep, CB or BC. Ray BC. Remember, it's a ray, so we would just put a line with an arrow on one end. Okay. Pretty simple to name angles. Feel good about that? Name all of the angles that have B as a vertex. Name all of the angles that have B as a vertex. What's one of them? GBC would work. That's a very large angle, but it would be that angle, right? GBC, from here to here to here. That's a very flat, straight angle, but that would work. Angle GBC. Sebastian, what's one? Angle 2 would work. That's talking about this angle right here. What would be another name for angle 2? Either GBH or HBG. Either of those would talk about that angle. Good. So angle 2 or GBH. What about another one that have B as a vertex? ABC. What would be another name for angle ABC? Again, I just start A, B, C. That would also be angle 1, right? Okay. So you could say angle 1, and what would be the fourth one we're missing? HBC, yeah, that one right there. Actually, we're missing 2. That's 1. HBC, angle HBC. Again, I went from HBC. That's that one. GBA. Yep. ABG or GBA, we don't have that one. Right. So I had HBC, angle GBA. Again, it could be ABG. The middle's just got to be the vertex. Is that all of them? Very straightforward, but if I had angle ABC, with points scattered around like that, I could say, name the points that lie on the interior of this angle. What would be the points that lie on the interior of this angle? H and G would be on the interior. Which points would lie on the exterior? W and X. Very simple. We know what interior means inside, exterior means outside. All right. And then we have 3 types of angles. Right angles, obtuse, and acute. Probably seen these before, maybe? And I'm going to show you how to use a protractor to measure these in just a minute. Right angles, how many degrees a right angle? 90 degrees is the corner of like a square, right? This would be a 90-degree angle. How we see that in our book is they will put this little box down in the corner so that you know that's 90 degrees. If they don't put that little box, you can't assume it's 90 because it might be 89.9, right? But if you see this little square in the bottom of an angle, that's a 90-degree angle. Right angles are all 90 degrees. Obtuse angles are what? Greater than 90. Yep. Greater than 90 degrees. Okay. So for example, this would be an obtuse angle because that is greater than 90. And acute angles would be less than 90 degrees. So an acute angle would be something like that. Right, acute, and obtuse. And just like we had, remember when we had 2 line segments and I said, are those the same? We had these tick marks, and if it had that tick mark, that meant those 2 lines were the same. Just like that, we have the same thing with angles. Oops. I had ABC, DEF. If there was this little tick mark in the angle that looked like that. In the book, they're pink, I think. That means those 2 angles are congruent. They're the same measure. So I would say angle ABC is congruent to angle DEF. That's what these tick marks mean. So if you see those little tick marks in there, I think they're pink in the book, that means those angles are the same. We also have angle bisectors. Here I have angle ABC. If I said ray BD bisects angle ABC, BD bisects angle ABC. Remember we did a segment bisector. What's a bisector do? What's a bisector mean?
Intersects another line.
It does intersect it. How specifically though? Bisector. Cuts it in half, right? Bisector always means cuts in half. So this piece, BC, bisected this entire angle. Which means this angle is the same as this angle. I don't know necessarily the 45. They could be. But because this bisected this entire angle, those two are the same. So you may get problems where I start putting variables in here and said, okay, well, if this is 4a plus 6, and this is 2a plus 2, or let's just make this 2a. Solve for a. Knowing this information, solve for a. Well, you know, since this angle is cut in half, these two are the same. These two angles are the same. So we would say 4a plus 6 is equal to 2a, because bisect means those two are cut in half. Solve for a there. Let's just, to make this more realistic, make that a minus 6. So I could add 6 to both sides, subtract 2a from both sides. I would get 2a equals 6, divide both sides by 2. A would be 3 in this problem. Because I set both those equal to each other because I know those angles were the same from the word bisector. Does that make sense? So, I want you to try this one. You have angle A, B, C. This is 8x minus 10. This is 10x minus 20. Again, I'm talking about the angles here. And the only other piece of information I give you is angle ABC is equal to 120 degrees. Solve for x. Angle ABC is 120 degrees. Solve for x. Try that. So if we have it, we know angle ABC, that's this entire angle, right? That's that entire large angle. Okay? That is 120 degrees. And the only thing it gives me is it gives me this piece of the angle and it gives me this piece. I know that if I add those two pieces together, those two aren't necessarily the same, but if I add those two together, it should equal 120, because the whole thing's 120, right? So if I take that piece of the angle plus the other piece of the angle together, the problem told me it's 120 degrees. Right? I took this piece, added it to this piece, together they're 120 degrees. So combine my like terms. 10x plus 8x is 18x. Negative 20 minus 10, negative 30. Add 30 to both sides. 18x equals 150. Divide both sides by 18. If we round off to 8.3. So x would be about 8.3. Okay? It would tell us what to round to. If not, we can just round to one decimal place. What if then, knowing that information, I said, find angle DBC. How many degrees is angle DBC? So that angle DBC is that one right there, right? That angle. The problem tells me that is 8x minus 10. Now that I know what x is, I can take that and plug it in to find out how many degrees that angle is, right? So I could take 8 times 8.3 minus 10. 24? About 56 and 4/10. So that's how many degrees this angle is. If I wanted to find that angle, I could do the same thing, or I could just subtract it from 120, because I know together they have to be 120. That makes sense? So when you see this little m in front of the angle, that just means the measure of. So knowing in this figure, this is all it's given me. Angle 1 is 2x plus 10, so I can just label that. That's that angle. This angle is 6x. Okay. I want to find what x is, and I want to find how many degrees angle 2 is. I don't know that these are equal. I don't know that those two angles are the same. There's no tick marks in there, and it didn't tell me that BC bisected this angle. If it told me BC cut this angle in half, I know those would be equal, but it didn't tell me that. What's the only other thing I know? That's a 90-degree angle, right? Together, those make up a 90-degree angle. I don't know that they're both 45 and 45. It could be, but it didn't tell me that. But I know together, if I add those two up, it should be equal to 90 degrees, right? Because that's what this little square in the bottom means. So, if I take 2x plus 10, angle 1 plus angle 2, that should equal 90 degrees. Like terms there, 2x and 6x is 8x. Subtract 10 from both sides, 8x equals 80. Divide both sides by 8. X would be 10. Part 1 of the problem is done. Part 2 of the problem, find the measure of angle 2. Well, I now know what x is. How many degrees is angle 2 going to be? 60. The measure of angle 2 is going to be 60 because I just plug in 10 for x. I wrote 10. Should be 60. 6 times 10. Which means I know this should probably is going to have to be what? 30. It's going to have to be 30 because the other make 90. If I plug in 10 though, 2 times 10 is 20. Plus 10 is 30. Before I go anywhere else on this one, I know BC bisects angle ABD, which bisect again means what? Cut in half. So I know that piece is the same as that piece. I'm going to put those tick marks in there. BC cut those two in half. Okay. Then if I told you angle ABC is equal to 2x and angle ABD is equal to 160. And then let's say find angle CBD. So a lot of different pieces of information here. First tells me angle ABC is 2x. So I'm going to put that in my problem. ABC is 2x, that angle. It tells me ABD, A to B to D, so that entire big angle is 160. So I'm just going to kind of write this out here. I know that whole thing is 160. The question is, find that angle. How do you know it's 80?
Because the C cuts in half.
Yeah, exactly. It cuts that in half. That's 80. If I wanted to, I could say, well, I know that's 2x, so that's got to be 2x. If I take 2x plus 2x, that should be equal to 160. That's 4x equal to 160. Divide by 4, divide by 4. X would be 40, which means if you had to find this angle, you would plug that back in, and it'd be 80 degrees. That's the algebra to it, but you know automatically if I gave you the whole angle, said it's 160, and I cut it in half, you know each of these had to be 80.